Good morning, everybody. So, in our today's class, we're going to see the next concept. That is what is reflection of sound. So, yesterday I have taught you about sonic boom and as well as speed of sound in different media. So, as we know that in different mediums, the sound will travel with a different speed based upon the density of the medium. The speed will changes. If the particles are very closer in a given medium, the particles are very closer in a given medium. So in which medium particles are very closer?
Solid.
Solid.
Solid medium.
So the
Solid medium.
particles are very closer like solids. Then the sound will travel more faster because the rate of transfer of disturbances from one point to another is very fast, so that the sound will travel also very fast. That's what we say is the rate of transfer of energy from one particle to another particle is basically depends on the distance between the particles. Distance between particles of a matter. So the particles of a matter is closely packed, generally we are saying, so that the speed of sound is greater. If they are loosely packed like liquids and as well as gases, then it will take least speed. For example, if you take gas like air is having almost least speed. So what is the speed of sound in air, everybody? Speed of sound in air at 0 degrees Celsius, 331 meter per second. At 25 degrees Celsius, what is that, everybody?
346
Yeah.
meters.
At 25 degrees Celsius, we are having 346 meter per second. So like this, in sound will travel least speed in air and light will travel maximum speed in air, which is, what is the speed of light? Everybody?
Into 10 power 8.
Into 10 power 8 meter per second. So that is what we studied. And then we studied that sonic boom. So if you all remember that, if generally the speed of light in air is 346 meter per second. So if any kind of object, let me consider the velocity of an object is v. If the velocity of the object is greater than the velocity of a sound in where? Everybody. Sound in air. That is only considered generally 346 meter per second. Then the sound produced by the object, we used to call it as a what? Everybody. Which is call it as a sonic boom. So who will travel faster than sound in air? Anybody? Who will travel faster than sound in air? Everyone. Fighter.
Light.
Yes. Flights, fighter jets and all. So remember, sonic boom means very simple. If any object travel faster than object, Mari, not light. Any object travels faster than sound in air, speed of sound in air, then that is called it as sonic boom. So, that is the speed which we used to call it as the speed of more than the speed of sound in air, which we used to call it as supersonic sound. What is the sound we used to call it as? Supersonic sound. Clear, everybody? So this is what you have to remember. So now let us comes to the today's class. So these are all the things we discussed in our yesterday's class. Okay. So air is not considered as a, sorry, light is not considered as a supersonic because light is not a particle. Object it is. Please remember. Clear? Light is not an object. Do you understand, everyone?
Yes, sir.
Yes. Any object will travel faster than the speed of sound. In air, that is also very important. Not speed of sound. Speed of sound is not constant in every medium. So in air, compared to the speed of sound in air, if any object travel faster, then that is what we used to call it as supersonic sound, which we used to say sonic boom. So now, coming to the reflection of sound, that is what is our today's class. Somebody call to Zayan. I want to know, I think Zayan wake up, but I don't know what happened. Mr. Lingesh, modify your name. Shivani join. Somebody called to Sangamitra also. So keep adding everybody. Reflection of sound. Okay. So now, you might be all remember class 8. You might be studied about the light chapter. Do you all remember light chapter you studied? My 8th class. Many of you. Am I right? Yes, please.
Yes.
Yeah. So if you have been notice it, light chapter, you might be studied laws of reflection. Anybody remember? Reflection. Reflection first. Let us talk about the reflection. So what do you mean by reflection? Simply a single word if you want to speak about reflection. Anybody can speak? Reflection just if you want to speak. So I can say bouncing back. Very good. So bouncing
Sir,
back of light. Is it right, everyone? Bouncing back of light.
sir,
Once, yes, who is that?
Graham is coming, sir.
Ah, okay, no issues. No problem. You concentrate. Zayan, modify your name. Yeah. So bouncing back of light. You concentrate on class silence and take the notes. So bouncing back of light after hitting the what? Any opaque surface. Any opaque surface, which we used to call it as reflection of sound. So basically, reflection of light. For example, if the light is traveling in a particular medium, so now it is going to hit the opaque surface, and then with the same angle, it will be bouncing back. So that is what we used to call it as reflection of light. So this is what you might be studied. Am I right, guys? Please respond. So in this case, you might be remember always angle of incident. Very good. Angle of incident is equals to angle of reflection. Is it right, guys? Please respond. Everybody. So that is what it
Yes.
is. So if I insert a incident angle with, for example, you have to draw perpendicular line. Perpendicular line we used to call something. Anybody?
Normal.
Normal. Very good. So 8th class, even majority people I have taught you. So that's what. So angle of incident. The angle between the incident ray and the normal is called it as angle of incident. So with the same angle of incident, the reflected ray bouncing back, that is what we used to call it as. What we used to call angle of reflection. Is it right, guys? Please respond. The same thing here. This is only call it as a second law of reflection, basically. So we have importance of this second law of reflection. This is a reflection of light or sound. This is reflection of light. Now, coming to the sound also will follow the same principle, that reflection of light. So reflection of light and reflection of sound is both same. So whatever it is, the bouncing back of light, same way here, the bouncing back of sound, when it will hit a hard surface, that is what we used to call it as reflection of sound actually. I hope you all understand, everybody. Similarly, how the light is bouncing back after striking the opaque surface, same way, if I take any kind of a hard surface, imagine like a cardboard. What is this one, everybody? If I take a cardboard, then if I speak or my sound is hitting the cardboard in a particular angle, then the same angle my sound will bounce back into the same medium. So here also angle of incident is equals to what? Everybody speak, guys. Angle
Sir.
of incident is equals to angle of reflection. This is only we used to call it as, what is to call? Reflection of what?
Sound.
Reflection of sound. So the principle behind the reflection of sound and reflection of light is remains constant. So same like how the light will reflect, okay, the sound also will reflect back after hitting the hard surface. That is what we used to call it as reflection of sound. I hope you clear, guys. Do you all understand? Please respond, guys. I want response. That is what you have to remember. Any doubt, please let me know, or else we'll proceed from here. Okay, guys? Yes, please. Okay, so that is what. So write it. So like how the reflection of light, same way, the sound also get reflected when it will falls on a hard surface. Write it. Definition. The changing, the changing of the direction of sound when it strikes a hard surface is called what is to call, guys? Reflection of sound. Do you all understand? Please respond, guys. Call it as reflection of sound. Okay. So here, what is the hard surfaces? That is immediate question. Sir, you know, sir, hard surface means. That is what? It may be a rough. What is that, everybody? Yes, please. It may be a rough surface, or maybe a smooth, or maybe a shining, or maybe a dull, like we can take walls, okay? You can take metal sheets, you can take plywood, you can take plastic, like anything, whatever is available, that is what is the hard surface. I hope I'm very clear. I want response to everybody. So here,
Yes.
as I told you, sound also obeys the what? Same laws of reflection as they obeyed by the light. So light, how many laws of reflection? I want response from the people. How many laws of reflection? Light,
First.
2 laws. Am I right or wrong? Yes. Anybody, any one of you, can you remember any one at least? Just already one law I already told you. That is what
Sir,
angle of incident equals to angle of reflection.
reflection.
Another one is
Reflection.
what? Another one is what? Another law of reflection.
Sir,
Yes.
the incident ray, normal ray, and the reflected ray
Normal
all
ray
lie on the
not.
same
Normal at the point of incident, all should lie in the
same plane.
same plane. Very good. So here sound also same, Agalya. So when the incident sound is falling at this point, then this point is call it as a what? We used to call it as point of what? Incidence. Clear, everybody? And that midpoint perpendicular line. What is the line? Perpendicular line we used to call it as, all of you, norm. So if I inserted incident ray here, incident sound here, does it reflect? A reflected sound will come at this point. Is it possible? Is it possible? No. And normal. Do you understand what I'm saying? So is it all should lie on the same plane, or they will be in different planes? Is it possible? Suppose incident ray in this surface, normal in this surface, reflected ray another surface. Is it possible that? I'm asking you. No. So all should
No,
lie
sir.
on the what? All should lie on the same plane. That is only the first law of reflection, first law of reflection of light, or first law of reflection of sound. Both laws are same. That's why it says sound also obeys the same laws of reflection as obeyed by the light. So please note it. First law. What is the first law? Everybody, the incident sound wave, reflected sound wave, reflected sound wave on the normal at the point of incidence. At the point of incidence, all lie in the same plane. Am I right? Then second point. The angle of incidence. The angle of incidence is equal to the angle of what? Everybody. Angle of reflection of sound. So this is what is the two laws of reflection of sound. Same like law of reflection of light. Anyone having any doubt, please let me know or else we'll proceed. So please write it, everybody. Make it fast. Any doubt, guys? You can ask. Help in understand? Zoyan? Yeah. Okay, are you doing?
Sir,
Yes, yes. Anyone want to ask me anything? You can ask. Or else we'll proceed. Clear, everybody?
Yes, sir.
So now, how to
sir,
verify?
out,
Yeah,
sir.
tell me.
Sir, the angle of incidence is calculated by the normal
Inserting
ray or
through the normal. Always between the incident ray and the normal is angle of incident. Incident ray,
okay, sir.
reflected ray and the normal angle of reflection. 10th class also, first chapter that only will study. So we have to remember always that. Okay?
Okay, sir.
Yes, now we'll verify it, how to do it. So if you take your experiment, your book is also given. So this is what is the experiment which is given. So all of you notice it, this is what we have to make the experiment. So you take it as a wall. As I told you, you can take any object, any surface. You take the cardboard, you take the wall, you take what? Many substances I have given you. Shining surfaces, metal surfaces. You can take any kind of objects. So it will obey the law of reflection. So what will happen? Experimental setup, you see that experimental verification of reflection of sound. So we have to arrange two kind of cylindrical cardboard pipes. You can take anything. Cylindrical cardboard pipes. Have you noticed it, everybody? I want response. Yes. So now you can fix this. You can you can take any point of incident. You select your choice. You can insert any point, your convenient. So what I am taking, this is what. So this is what we used to call it as. What we used to call all of you? We used to
Point of
point of incidence. And the perpendicular line passing through that, what is that call it as? Perpendicular line passing through that, which we used to call it as? Yes, Abraham, we can say. So, okay, so now, all of you observe, here normal, it is wrong. Which is normal? This straight line is the normal. Here they have shown is wrong. Clear, everybody? All of you? Yes?
Yes, sir.
Yeah. So now I fixed, I take the point of incident and I will draw a perpendicular line. This perpendicular line is what actually? The perpendicular
Normal.
line, normal. I will imagine it is imaginary line. It is not existed. Now I fixed two cardboards with a particular angle, my choice. So I am taking angle of incident I. So I will fix with the cardboard maybe 20 degrees, 30 degrees from the normal. So from the normal, then only one cardboard, guys. Now this side I am putting the clock. Clock for what purpose? Anybody? What
Sir,
purpose?
for sound, sir.
Yeah, for production of sound. So now another cardboard I'll take. and I will try to hear this clock sound through this pipe. And if I am keep on adjusting and check it, at a certain position where I can hear the clear sound of this clock, at that point, if I fix my cardboard and I check here, see, they have not drawn the ear diagram properly. This is the person who is lying on the bench. That is what they're showing. So this is the ear. So then you can measure the angle between this cardboard and this normal. Then this angle also equals to angle of incident. That is what we used to say. What is that call it as? Everybody. Yes, please. All of you. Angle of, what we used to call? Angle of reflection. Now, immediately there is a mind, you all people can ask me. Sir, if I put a cardboard and I can hear, I cannot hear here. I cannot hear here. I cannot hear here. Yes, everywhere the click sound of a clock is audible. But how you can fix only this position, sir? What is the secret? Anybody? The click sound of a clock becomes maximum. Do you understand, everyone? So adjust the angle of the tube. You can hear anywhere. You can from here, or here, everywhere. Wherever you can get the maximum click sound, that is the point, original exact reflection. Do you understand, guys? All of you? Agalya?
Yes.
So I adjust the angle of a tube. This is the tube A. Let me take it. And this is the tube B. So you have to adjust the angle the tube B is making with the normal. Do you understand, everyone? So in such a situation, the ticking sound of a clock becomes maximum. Whenever it is become maximum, that is our angle of reflection. Is it okay, guys? Everybody, please respond. Yes? All of you?
Yes, sir.
At that point, you can fix your cardboard and you can measure the angle. That is what we used to call it as. What we used to call? Angle of reflection. Angle of reflection. So that is what you have to remember. So you can measure the angle of incident and reflection and see the relationship between the angles, how it will be. What is the relationship between angle I is equals to
Angle.
is equals to angular. So we have to adjust the position. See, adjust the position of the pipes so that you can best hear the sound of the clock. The best hear audible sound to you is the angle of reflection. That is what you have to note it. So this is what is the experimental verification. We can prove that angle of incident is also following angle of law of reflection is also following sound also same like light. That is what you have to remember. Is it okay, guys? Please respond, guys. So both it will verifies the two laws of reflection. What is that? One is incident sound and reflected sound all should lie on the same plane. Second one, angle of incident of a incident sound is equals to angle of reflection of a reflected sound. So that is what you have to remember. Is it okay, guys? I want response. If you have completed this, then you have to read this also. In our book also, you have to go through that and you have to make it. This experiment you can verify in our home also. If you're having a wall clock, if you are having a normal stop clock or anything, stopwatch or your phone, you can put it and you can verify this. If you're having two cardboard pieces, sir, how cardboards are? Do you all know agarbattis? Agarbatti pipes. Do you remember, everybody? While selling time,
Sir.
agarbatti, it will come in a cardboard. Am I right? Some brands, agarbattis in English, incense sticks. Incense sticks, தெரியுமா? Arey God will pray correct. That is.
Yes, sir.
They will come basically in a pipe, normally cardboard like cylindrical pipes. So in that pipe, like the two pipes you can collect and you can consider your wall is also, your wall is a reflection of sound and you can select and you can put your phone or your something at this one point and opposite side, Zion mute, wherever you are hearing the best best sound clearly audible, then that is the point you fix it you will get angle of incident is equals to angle of reflection if you measure it. So that is how you can all verify in our home also. It's nothing required, even no harmful, dangerous things. So even guidance of somebody, presence of somebody is not required at all. So that's what you have to remember. Is it okay, guys? Everyone? All of you?
Yes, sir.
Yes. So that is what is experimental verification of reflection of sound. So how to find angle of reflection? Wherever you find the maximum sound clearly and perfectly, that is what we used to call it as angle of reflection. So after this, we are going to study the another beautiful concept and the most important concept in the sound chapter. That is what we used to call it as, what we used to call, anybody? Echo. Okay. So this is the another important concept for numericals. Okay. And which will be the beautiful phenomena, natural phenomena, which we can notice in our hilly regions and all. Majorly like a mountain cliffs and all, we can notice. So movies and all, you might be watch a hero or heroine will go and shout near the mountains, mainly like this Munnar areas or this Ooty and all. You might be all experience it. Whatever they speaks, their voice will be reflected back. Have you all noticed it, everybody? Is it? Please respond, guys. All of you?
Yes, sir.
Yes. So that is why we used to call it
Sir.
as echoes. So echo simply, if you want to say, is that a reflection of your sound, your voice, whatever you are speaking, which will be reflect back. That is what we used to say is echoes. So for example, let me consider there is a mountain. If I consider there is a mountain or hilly region, so now, suppose I am the person who is standing here. So I am speaking now. So my sound will goes. It will hit. Okay, like that it will travel. It will hit the mountain. And from the mountain, my same sound will be again reflecting back and it will reaches to me. So this is what we used to call it as, what we used to call, everybody, echo. Okay. So echo produced by hilly areas. So you can all experience it. Have you experienced it, anybody? Ooty and all, Kodaikanal, Ooty, many places we have. Okay. So many places we can hear this sound. Even empty auditorium, even our school auditorium, of course, it is now it's many years over, but still you can see all of you. If you are alone, like we can say, all are present, no problem. But if you are in alone, if you speak something also, your voice is trying to reflect back to you. Like somebody is others again speaking, your same voice will experience it. Am I right, guys? I want it. Response. Or else any
Sir.
newly constructed building. Have you all noticed it? Newly constructed building or under construction. If you try to enter, or else new house inauguration, or somewhere if you travel, you might be all experience it. If when you are trying to speak inside something, again your voice will be coming back to you. Am I right, everybody? Yes, please.
Yes, sir.
Yeah.
Yes, sir.
So that is only we used to call it as echo, voice back. Voice back. We can hear your voice back. That is what we used to say is echoes. So you might be notice it, a big empty halls or in front of a mountain or a deep valley. Okay, deep valley. You can hear your voice back. So that is what we used to call it as echoes. So even some movies, you might be notice it. Okay, so just what is that movie? Yeah, 1 minute. I will even show you because it will be impact. You might be remember that exactly the name. I don't know. So 1 minute. Yeah. Yes.
Sir,
So
I have doubt, sir.
yeah, tell me.
Sir, why this concept is not working in the normal war, sir?
Because See, if there is a something, what we can say is objects are very like many objects are there. Good observers will be there. For example, normal house, many things are there: curtains, bowls, utensils, and varieties. Your laptop, desktop, your cloth, many things are there in our house. Am I right?
Yes, sir.
Yes. So they will observe your sound. But if it comes to the empty hall or mountain regions and all, so their observers are less, so that it will lead to the reflection. Do you understand?
Yes.
Are you clear? Yes?
Yes, sir.
Yeah. So
Yes,
there
sir.
is a small scene. You can notice it. So there is a movie actually Happy. The movie name is Happy. So here you can see that. I think it is in a Kodaikanal only. So let us see that. So what will happen? But it is reflect here. He is saying that he is showing. You can notice it. Basically, here, okay, we don't want so much time. So here, basically, when she will speak something in front of that hilly areas, again she can hear her sound back. So that is what we used to say. So we can experience it. Even many of you might be go to Ooty and all. You can experience. There is a particular spots where we can experience your sound back. So that is what we can notice it. So in front of a mountains or deep valleys, you can hear your voice back. All the points you noted. Empty rooms, empty halls, or in front of mountains, in front of a mountain or mountain cliffs, we can say, so tall mountains, deep valleys, you hear your voice back. So that is what we used to call it as echo. So yeah, inside caves also linguists, yes. So you can hear the word, whatever you speak. So you can say hello, hi, how are you, whatever you speak, the repetition of the original sound will takes place. That is what we used to call it as echoes. So the sound is an echo of your original sound. That is what we used to say is echo. So please write it. An echo is the repetition of the original sound. New houses, you might be experienced this. Am I right, guys? All of you? New house. Am I right? The echo is the repetition,
Yes, sir.
repetition of the original sound, original sound of a source by reflection, from an obstacle or distant object, that is what we used to call it as echo. Okay, everybody. So when whatever you are speaking, if that same voice is reaches back to you after striking the obstacles or any kind of object, that is what we used to call it as echo. So any doubt, anybody? Please respond, guys. All of you clear? Yes? Yes. So
Yes.
now here, if you want to hear the echo, suppose, sir, I am not interested to go to mountain, but still I want to hear the echo, then you can make certain conditions for production of echo. If all our conditions are satisfying, definitely you can produce the echo in anywhere. That is what you can do it. Okay. So that's first condition. So, do you all understand about what is echo? Agalya? Clear? Yes. So this is what. Now let us discuss what is this echo and how far it is going to be worked out. It is how it is producing. So now coming to here, all of you, the first condition. So all of you write it. Conditions for the production of echo. Conditions for the production of echo. Meeting is going to end. Again, join back fastly. We'll try to finish this concept today. Then we can go with the reverberation. Tomorrow we'll go with reverberation. Right. Conditions for the production of echo. Conditions for the production of echo. First condition, what I told you, only in some places you can hear the echo. What is that places?
Hilly area.
Yes. Yes. That is,
People.
yeah. Size of the reflector must be large. That is the first condition. Size of the reflector must be